So today we will talk about MySQL server. And the question is, can MySQL server attack you? All right. So my name is Alex. And my background is MySQL. I have been doing MySQL consulting, open source consulting for a long time. I started at MySQL AB, the company behind MySQL. And we got acquired by Sun Microsystems, Oracle. And then I joined Amazon Web Services about 4 years ago as a database engineer, and I switched to security. So security, open source security research, Linux was my hobby for some time. My interest in offensive security started playing capture the flag games. And I currently lead what we call the database security team. We call it Red Team at AWS. So this is what we are going to demo today. So imagine that your website have been hacked. The good news is there's nothing important on this website. It's a static website. And you can simply reload the data, right? You can restore from the backup. So what do, you connect to your own MySQL server to upload your backup. And now, this website, right, and the MySQL server is owned by the hacker. So now, you have been hacked. Your laptop, your workstation is now under control of this guy because you just has been connected to your own server. So the question is how it's even possible. And this is what we will be, I will be presenting today and demonstrating, doing some recorded demo. But this is our agenda. And I will talk about the whole thing beforehand. So there is a remote code execution in MySQL and MariaDB client library that has been silently fixed in 2019. And we will be describing this issue and demo this issue. Now, about a year ago, my team, me and my colleague Martin, has found a bypass to that fix. So the fix has been released, but we found a bypass, right? And we reported it to Oracle, and Oracle fixed it. There's a CVE for that. So I will be demonstrating two issues today. The first original one, remote code execution, and the bypass. To really understand why this is happening and how this is happening, we need to understand MySQL protocol. So this is the MySQL protocol oversimplified, where we have MySQL client connect to the server. And what the client is, the client can be your MySQL command line client, where you establish connection to the server, or it can be any GUI tool, like Workbench or whatever GUI tool you have. So here is how this handshake happens. MySQL client establish the connection to the MySQL server and say, hello, MySQL server, authentication, please. I have a username and password. And I will also use the plugin. The original plugin called MySQL Native Password plugin. So MySQL has been created a long time ago. And MySQL has a lot of pluggable stuff in it, including the authentication plugins. You can also write your own authentication plugin. So what MySQL server will reply here is, it said, very good. I loaded this plugin, the MySQL native plugin, and I checked your username and password hash using this plugin. So access granted. Now, another situation. MySQL client also connects to the server, same thing, and say, I would like to use whatever plugin. And the server will say, nah, I have no idea what whatever plugin is. Let's try another plugin. And the client complies, right? And the client will say, okay, if I have that whatever plugin, I will load it and use it. So let's take a look at the source code of MySQL to understand what is happening here and what does it mean that the client will load it. So MySQL server can tell the client which plugin to use. And MySQL client will actually try to load that plugin, right? What does it load mean? The load mean simple. Plugin is a shared library. So the client will simply do deal open on Linux or load library on Windows. And when I saw that first time, I was like this. How come? Where is the protection? So then let's go into the source code and see what kind of protections do we have. So this is the real source code of the client library. So what do we have here? We have the plugin name. So this is the string, right? This is the string that will be sent over to DLOpen. And this is how the string is being built, concatenated. So we have a plugin name, and the plugin name comes from the server. But we also have a plugin dir. It's a directory where the plugin lives. And we'll load that. We'll load that shared library. So if the server will tell client to load it, it will try to load it from inside the plugin dir only, right? Okay? What about this? It's a directory traversal, right? So we can pass a rogue server, can pass this dash dot dot slash and actually load a shared library from an arbitrary place on the client side. Again, client is your machine, is your workstation. All right? So this is actually an arbitrary code via directory traversal, arbitrary code execution. So that has been found in 2019 as a report at HackerOne, and that has been reported against MariaDB. So MariaDB is a fork of MySQL. They don't call it a fork anymore because it became a standalone server, but actually lots of code is shared. So that has been filed, and this report actually talks a lot about why this is bad, what kind of things can happen, and so on. So on June, it has been reported and it has been fixed. And the fix has been released in MariaDB. So let's take a look at the fix. So they do the right thing. The name of the plugin, the name, does not need to contain the directory, doesn't need to contain the full path. It's just a name. So they just sanitize it, right, and return an error, invalid plugin name. So it has been also pushed in MySQL community. And this bug has been fixed in MySQL community. Usually, Oracle MySQL doesn't disclose any information about the CVEs. They just fix it. That's why I was saying they have silently fixed that. Now, we always can search for the commit. And the commit message actually have a lot of information. So if you want to know what kind of CVE is there, you can now always go to GitHub and search for commit. So this is clearly talking about the bug that has been fixed. All right. Now, this is the fix for MySQL. And this fix is completely different. It's using a different approach compared to MariaDB. In MariaDB, they just simply find all the symbols. This actually finds the separator, and if it includes the separator, returns an error. So this is the quick summary of 2019 issue. And next, I will show the real example of how we can exploit that. Right? So how does the exploit works? What do we need to actually exploit that? We need to have control over MySQL or MariaDB server. The version of the server doesn't really matter. It's the version of the client that matters. We need to have a vulnerable old version of the client, and this is our MySQL database administrator who is connecting. And we need them to use the MySQL command line or any client like GUI tool. So what do we need for doing that exploitation? We need control over the MySQL server. We need this guy, MySQL database administrator, to use the old version of the client library. And we need the ability to push the code from the server to the client, right? Because MySQL server doesn't have that. So sounds complicated. Let's see how we can actually achieve that. So the first thing what we'll need is we need to create a rogue MySQL server. There are a couple of ways how we can do that. First, we can take the normal MySQL server and create a plugin. But I found the easier way to do this. I found that you can use Python, and Python has implementation of the MySQL protocol, MySQL binary protocol. So here's our plan of attack. We will write a rogue server with the ability to push a plugin name. We will load the arbitrary file as a shared library, and then we will push this code to the database administrator machine. So how do we push the bad plugin name, the plugin name that contains a directory traversal, from the server? There is a Python library which is called MySQL Mimic. You can install it with a pip install MySQL Mimic, that's it. And then you can start writing your fake MySQL server. So we import this MySQL Mimic, normal stuff. What we'll need to do here is we'll need to create our own implementation for the couple of classes. We'll need to have a custom identity provider. And in the custom identity provider, we will simply push the plugin name, and the plugin name now can contain our directory traversal. Right, so now I have this Python file, fake server, and this is my main function in the Python. So I can just run this script and specify the plugin name containing directory traversal and the port. So let's try it out. At this point, we just want to verify that our client will try to load the arbitrary shared library from the arbitrary path. So I use this ODBC driver. This ODBC driver using a pretty old MySQL client version, driver version 8018. And then I try to establish the connection. And here's what happens. It clearly tried to load something, but it failed because the path doesn't exist. But we have verified that our fake server is working, and we can push an arbitrary plugin file name, right, containing the directory traversal from the server to the client. So the next thing is, how do we execute our code as a shared library or from the shared library? So the plugin is actually the plugin that has symbols, right, exporting the symbols. But really, we don't need to worry about that. On Linux, it's so easy because everything that you put inside init will always be triggered, will always be executed. So this is the super simple, poisoned shared library that can be used as a MySQL authentication plugin. Actually, this will fail on MySQL side, but the code inside init will be triggered. So here inside this code, I'm creating a simple file in TMP, and also I'm opening a calculator on my Mac laptop. And then I compile the shared library normally. So also, what will be nice actually is that we can name the file. We will have the full control over the file name, because what we can see in the code is this SO extension is being appended. It's either .so or DLL on Windows. So let's look at the source code again. And this is probably the oldest source code that is still in your MySQL server. So if you're using MySQL server, this code is in there. So this is from 1984, written by Richard O'Keefe, who is a very famous computer scientist at that time. And it has a function in it, right? It's an implementation of string copy. But what you can see here is you're looking at a buffer length overflow. Now, if we control the name, we can create a name which is larger than 512 bytes, which is defined here, fn rel len. And if we will do that, then we will push off the extension that is being appended. So it's not an overflow in terms of you can corrupt the memory, but you can actually corrupt the string to the point of where you can skip this last part of that string. So now the only thing we need to do is to compute the length of a string so that it will push off the extension part. So this is again the rogue server. I need to add the function. So I created this function. Don't judge me on the Python code quality. So this is a very simple function that will calculate the string. The idea is simple. On Linux, you can do whatever number of slashes. It doesn't matter. It will always load the file. So I will calculate the exact amount of slashes, starting with the 512 minus the plugin dir name, minus the length of my file, and so on. And then I will generate this giant string, and that will allow me to load arbitrary file from disk without the SO extension. So now I just put this function in, and I start my server again. And now I can disguise my shared library as a picture. If I put the TMP something PNG, and I inject the string with a precise number of slashes in it, then I can load it. And let's take a look. So I start my server, I generated the string, and then the client will connect. I'm using MySQL command line client here. And then it gives me an error. But I know that it worked. How do I know? I can use the strace to actually see what's happening. I can profile my client. And then I can see open add. So it's actually opened my file, and next what it will do is it will do a deal open on it. So we have successfully overflowed the buffer. So now we have the ability to load an arbitrary shared library from the database administrator, from your workstation. So the last thing is, how do we deliver this code actually to our victim? And one way to do that is to use a little bit of social engineering. So we can disguise this as a resume. So think about this. If I send you the resume, my resume, what you will do? You will probably save it on disk. You don't need to open it. You don't need to execute it. You don't need to do anything with it. The only thing that I need is this file to be on disk, because then I can trigger it. Right? So I send the resume, you save it, and now you connect to the server, and now the server will attack you. So this is a quick demo, recorded demo of how does it work. So I have two machines here. On my VirtualBox, I have my server. This is the rogue server. And then on my MacBook, I have this shared library, which is actually resume, right? Martin's resume. Martin is my colleague. And let's see how it works. So what will happen is that the calculator will be triggered. This is the file that I want to trigger. I start the rogue server. I put the resume in. I put the port. And then our victim, me in this case, will open a Workbench. This is the old version of Workbench. Issue is unfixed at this point. This is 8013, which is pretty old. And now I just simply establish a connection to my hacked database. And I have the plugin dir here. So now I just click connect. A calculator came in. So that means that my workstation has been indeed hacked. All right, so now it gives me an error because it doesn't have the normal function, it doesn't do authentication, it doesn't do anything. It's a fake rogue server. The whole purpose of that is to execute the code. All right. This is the Windows demo. It's pretty much the same. I think we have time. So that's same on Windows. We will open a message box here. And we have this DLL here somehow pushed onto this box. And then we will open a workbench again, establish the connection. This is old workbench. I'll establish the, just to demonstrate that there is no plugin dir needed to be configured on Windows. It doesn't matter. So it's actually easier to tag. And here we go, pond. So, and we can also see this in the process list. All right. So now, again, that has been fixed in 2019. But now in February 2023, we have discovered a new security issue, a bypass to this fix. So the quick timeline here, in February, we discovered the issue. On April 18, the issue has been fixed. And we got CVE here, and we see the commit. So let's look at this code. This is the fixed code, right? No paths allowed. Right? So anything you see weird here with this string copy function? The first parameter is interesting. Right? The first parameter is CS. That's a char set. So MySQL supports different character sets. It supports UTF-8, it supports native languages and stuff like that. But it also supports UTF-16, UTF-32, and others. So what is the difference? In UTF-8, the number of bytes depends upon what kind of character it is. If it's Latin, English character, right, it's 1 byte. If it's something else, like Russian, it's 2 bytes. If it's Chinese, it can be 3 bytes or 4 bytes. On UTF-16, it's always 2 bytes. So what will happen here? It will do the comparison based on the character set. And the comparison is against bytes. So if we pass the 2 bytes character set, what will happen? It will skip. It will skip over 2 bytes. And because the fix is very simple and straightforward, you just go through the string and try to find this slash thing. If we will be able to provide the character set, then it will skip over this slash thing in the comparison function, and then we bypassed the fix. So this is exactly what happened, right? And this is the description of the actual fix, 2023 fix, right? So MySQL, Oracle MySQL call it impermissible character set. So basically what happened is that the client was not supposed to use that character set. It was not supported, but eventually it did. So this is the newer workbench, and in the newer workbench, this is after the first fix, we can see that it's still vulnerable to the bypass. So what you will need to have, and this is the limitation of this fix, is you need to somehow push the character set. So if a database administrator for any reason will configure your connection in Workbench or MySQL command line client to use the UTF-16, then this thing is still vulnerable. So this is the demo of, I hope it, yeah, it's good. So this is the demo of the exploitation on Windows with the command line tools. So we are using the MySQL version. Let's see what version it is. 8032. So this is after 2019 fix, but before the final fix. So if we connect to the rogue server, we can see that it doesn't allow you to do this, right? But if we will use default character set equals UTF-16, then it will actually pawn us, right? Because it skips over. So we'll also need to have we need to have this name to have the even number of characters, so that it will skip over by 2, and then it will not find our slashes. All right, so it has been fixed in the latest MySQL version, and let's verify that it has been fixed. So now we're using this 8033 version, which is released last April, last year. And now we will try to do the same thing. The original fix is there. And if we try to do the default character set equals UTF-16, it also works with the UCS and UTF-32, right? Now, this has been fixed. So the fix was super simple. It's actually just checking if the character set is permissible or not. So they just disallow the UTF-16 and the UTF-32 and stuff like that. All right, so we have verified that the fix is valid. And this is our attack, done. So what we have done is we wrote a rogue server with the ability to push the plugin name, and this plugin name is actually a file name with directory traversal. We have created an arbitrary file with as a shared library, right? And we are loading that resume file as a shared library, right, into the database administrator machine. So again, a quick recap of the versions affected. 2019 issue, the original one, it's older version, so if you are still using your client from 2019, then you need to upgrade immediately. 2023 issue, that only affects the MySQL server and Percona server. Percona server is another fork of MySQL. And the fix is released April 2023. So if you're using older MySQL command line or GUI tool, you will need to upgrade as well. So this issue, this class of issues, affects the GUI tools based off the C library, C, C++, the native MySQL implementation of the MySQL driver. So that means that the MySQL command line tools are affected, connectors are affected, ODBC, GDBC is not affected. So any native implementation, like GDBC or Go or Python native implementation is not affected. The issue is actually in the MySQL code. And finally, the summary and conclusions. So rogue MySQL server can attack you. The database administrator or anyone who connects to an untrusted server, a rogue server, it can be a hacked server, or it can be a server that is affected by man-in-the-middle attack can actually push and load an arbitrary code on your machine. The original issue is fixed in 2019. The new issue fixed in 2023. And a couple of takeaways. Using a multi-byte unsafe functions is not a good idea. If you have a C function written in 80s, and you're passing a multi-byte string to it, you need to look at it and probably rewrite it and always upgrade. So that's it. Thank you very much. Any questions?
Yeah, Alexander, so just to start off with, you talked about the disguising that shared library as a resume file. Is that embedded in a valid PDF, or does it just have a .pdf extension?
No, it's just a file. The file, if you open that PDF file, it will give you an error because it's a shared library. It's a binary code. It's executable code. Right? But it doesn't really matter. You don't need to open it. You don't need to do anything with it. If you get a resume, right, you will save it somewhere on disk, first of all. That's it. If you save it, that's it.
Any other questions? And if you've got a question, come up to the front, and that way you can say it into the microphone and we can record it. Yeah. Sorry, if I could get you to come to the front so we can make sure the answer is recorded. Thank you very much.
So would you say that a good fix or a best fix is to restrict the client to only be able to communicate to SQL at a secure IP address or server location?
Yeah, that's obviously a good idea, right? So but there are two things here. The first thing is, if your server has been hacked and you're connecting to untrusted server, it doesn't matter what you do. You connect, you get hacked. You think that you're connecting to the right server. Now, usually the answer to protecting from the rogue servers is TLS, right? And the verification of the certificate. SLTLS verification of the certificate that server presents. But in this case, it will not be useful because you're connecting to the server, your server, which will probably be the same certificate. The hacker will really use the same certificate. But now, if in another scenario where there is a man-in-the-middle attack and someone has changed maybe the DNS name, right, to point to another server, then verifying this SSL certificates is a good idea, to restrict it. But again, you need to think that this is a reverse attack. Usually we think about MySQL server and protecting MySQL server from the attacks and do the firewall rules to protect the MySQL server. This is the other way around, right? So this is the protocol issue in MySQL which will allow it to load the plugin.
Any other questions? Okay, with that, let's thank our speaker. That was excellent. Thank you very much.
Thank you very much.